All right, guys. So, in the previous section, I introduced right the equations that you are gonna use to find the center of mass for a uniform solid of revolution. These were the equations we introduced previously, right, guys? Okay, so now we are gonna actually use these results. Okay, so you are actually allowed to use these results. Okay, you don't have to. Now you saw in the previous section when we were dealing with 2D objects, you had to always break it into strips, and we had to apply it from the beginning using calculus, right? But over here, you can actually use these results to actually get the center of mass of any solid of revolution. All right, so you can directly quote these results. Okay, so under this particular topic, the first thing, okay, so now we are going to go into 3D objects, basically solid of revolution. So the first object we are going to discuss under that is the center of mass of a uniform right circular cone. All right, guys, the center of mass of a uniform right circular cone. All right. This part. Okay, so how does it work? Okay, so you can see here, the thing is, you can see, now I've constructed a cone here, but the thing is, now how does it start? Okay, how does it start? Because, okay, so you can see here, let me, all right, guys, so looking at this, have a look at what's going on here. Now you can see in this, in this particular graph, I have drawn a straight line. Can you see? So first thing first, I'm just showing you the straight line. So, in solid of revolution, what we do is we simply, I mean, whatever the graph they give us, we rotate it 360-degree around the x-axis and we create a 3D object. Right, guys? Now, the thing is, when it comes to a right circular cone, okay, you need to think, okay, you need to think, what is the graph, okay, what is the graph, the graph we need to rotate in order to create the cone, because we are trying to create a cone. So how is it created? Now you can see I've drawn this straight line that goes through the origin. Okay, so we are rotating 360-degree around the x-axis. So do you see what's gonna happen here? All right, guys. So over here, the open end actually. Now you can see when you take this particular line and rotate it 360-degree around the x-axis, guys. I need you to understand that this line is reflected to the other side, and the open end actually makes a circle, right? So you should be able to see that it actually what this particular line is creating a cone, right? So a cone that's symmetric around the x-axis, right, guys? Can you see? So I've taken the radius of this cone to be capital R. Okay, and then we'll take the okay. So radius of the cone is capital R, and let's say the height of the cone is H. Can you see? All right, guys. So one of the most important things here is, guys, now this is the original. Now I'm actually shading in yellow. So this was the original graph, right? So we used this original graph and we rotated this yellow line 360-degree around the x-axis in order to create the cone. Okay, so the most important thing here is how do you get the equation of this line? Okay, how do we get the equation of the line? Now you can see I've written it over here, but how did I get this equation? Now y'all know that this is a straight line that passes through the origin, right? So if it's a straight line that passes through the origin, the format of the line should be y equal mx, right? Y equal mx plus c, but c is 0 because it goes through the origin. And then the main equation of the main line, okay, remember you always need the equation of the original line. That's needed because we need the y value here in order to substitute values to our equation. We need the y equation. All right, so that's really necessary. You must find that. So I can see that this original line is of the format y equal mx, and the gradient is guys, as you can see, the gradient is the y difference over x difference. So y difference is the r value here, can you see, and the x difference is this h. Can you guys see? Y difference is the r and the x difference is the h. So gradient equal r over h, and that's why I've gotten here y equal r over h times x. So this is the equation, the main equation of this. But I mean, this is the main, I mean, the most important thing we require here, because we require the equation of the line in order to go for the rest of the, in order to calculate the center of mass. All right, guys. And then the next one, and and you guys can see now definitely this is rotating around the x-axis. So the center of mass is surely somewhere on the x-axis, right, guys? So if it's on the x-axis, the center of mass is on the always on the line of symmetry, which means even before we start, we know y bar is 0, right, guys? Because the center of mass is definitely on the x-axis. Okay. All right. So now time to input the values into our equation. So I'm trying to, and you can very clearly understand, I'm trying to find x bar, right? We don't need to find y bar. Y bar is already known because center of mass is surely on the x-axis. Okay. Right. So we have two equations here. So either you can go with the first one or the second one. But however, to go with the second one, remember, as I told you, you need to know the math. Okay. Okay. So first, we'll go with the first one. Okay. So let's practice with the first one. All right, so you can say I have written the equation here. X bar equal integration of y square x times with respect to x over integration of y square with respect to x. Can you guys see? And so the integration is happening with respect to x. So I have used the x limit. Can you see? 0 to h. I have used the x limit here. So y square x dx with respect y square x with respect to x, integration limits are from 0 to h. And integration of y square dx, integration limits are from 0 to h. Can you guys see? And then the next important thing is, guys, you need to, another thing is your integration is happening with respect to x. So you need to convert everything with respect to x. So you can't have any y terms here. So that's why I already have the y equation. Y equals r over h times x. Can you guys see? So the next thing that we do is we replace the y here with r over h times x. Can you see? With r over h times x you replace. All right, guys. And then it's time to simplify and it's time to input the integrate and then get the answer. Okay, so let's give an attempt for the integration. All right, guys. So let's perform the integration. Now, when you're doing the integration, make sure you do the integration for the numerator separately and the denominator separately. Right, guys? The numerator separately, denominator separately. So the numerator is going to be r square over h square times x square into x. Can you guys see? And the denominator is going to be r square over h square times x square because the square goes to everyone. And guys, the integration is happening with respect to x, right? The integration is happening with respect to x, which means any other term, r and h, they are all going to be constant because your integration is happening with respect to x. So x is the variable, right? So you can bring r square and h square out of the integration sign. Can you see from both the numerator and the denominator? Okay, only the integration happens with respect to x. Therefore, x is the variable here. The other letters are treated as constant. That's how integration works, right, guys? So then you take these guys out and then you are remaining with integration of x cube. I hope you guys can see how I got x cube, right? Because it's x square multiplied with the x to give x cube. And over here in the denominator, I have integration of x square, right, guys? So let's finish it off. So the r square over h square cancels out. And I end up getting here x. So when I integrate x to the power 3 in the numerator, I get x to the power 4 over 4. And the integration limits are from 0 to h. This guy, I get x square integration is x to the power 3 over 3. 0 to h, guys. If you want, you can perform this integration of numerator and denominator separately like we did previously. So you don't have to do both of them together. But actually, this is quite a simple integration. So we can do it together. But if you want, you can, do this separately and then input the values into the answer. Okay. So it's going to be replacing this h to the power 4 over 4 minus 0 divided by h to the power 3 over 3 minus 0. Right, guys? So we end up getting here h to the power 4 over 4 into 3 over h cube. Right, guys? When you simplify, so I end up getting x bar as 3h over 4. So this is a really important result, and sometimes these results you are allowed to use them. Okay, sometimes they tell you that you are allowed to use the results, but you will also be asked to prove the results. So depending on the question, okay. But anyway, you need to understand that the center of mass 3 is what is at a distance of 3h over 4 from where did we measure? I think you can see we use 0, 0 for the vertex of the cone, right? So the center of mass is at a distance 3h over 4 from the vertex of the cone. right? So this center of mass is at a distance 3h over 4 measured from the vertex of the cone. That's really important, which means the center of mass is at a distance h over 4 from the plane face of the cone. So that's also good to know. If it's 3h over 4 from this side, then it's h over 4 from the plane face. Okay, so that's also needed. Right, guys? So this is really important. The result you must remember the result. Also, you must be able to derive and get the result as well. All right, guys. All right. So, guys, now we'll move on to the next shape. So, the next shape we're going to discuss is the center of mass of a unit solid, a uniform solid hemisphere. Right, guys. So, this is a hemisphere. You can see I've drawn a hemisphere of radius capital R. Okay, and you know the equation we are going to use, right? So once again, the main equation that we are going to use is the same guy that we discussed previously. So these are the equations that you have to use, right? So these are the pairs of equations to use. So basically, for x bar, you'll have to go with one of these two equations, right, guys? So either you'll have to go with this one or the other one, right, guys? So you'll have to go with one of these two. All right, guys. So now, in order to use this equation, you need to identify one major thing, right? So you require now previously also you saw I was trying to see now in this shape. I was trying to see what was the major the original graph, because it's the original graph that is rotated 360-degree around the x-axis in order to create a 3D object. Okay, so previously in the previous case, the original graph was this yellow color line, and that was the main y equation. That's what we use in the equation, right? So we use the equation of the original curve that was used to rotate. So now over here, you again have the same situation. So now you need to ask yourself, in order to create this solid hemisphere, what is the 2D graph? Because first you need to draw a 2D graph that is rotated 360-degree around the x-axis to create this 3D object. So you have to ask yourself, what is the 2D object that you are using to do this? So what is the 2D object that we need to draw in order to, rotate to create this? So what do you think about that? All right, guys. So over here, I mean, the 2D graph that you need to consider here is, guys, so if you look at it, it's a simply a semicircle. It's not a semicircle actually. It's actually a quarter of a circle, right? Because if you take this part, right, guys, so you can see that these two are this is the part of the circle you have to draw. So this is already on the x-axis, so this point doesn't move. You know how it works, right? So when you draw a line, when you're, now this is the original graph you need to consider. So look how this rotates to create a 3D hemisphere. Then when you are rotating, you have to just reflect the same graph to the other side, and any open end becomes a circular face, right? So you can see now I've reflected this to the other side, and this is the open end. Can you guys see? So this open end becomes a circular face, and that's how you create the semicircle. Can you see? That's how you create the hemisphere. The open end over here, okay, the open end to create the circular face. Right, guys? So basically, what I want you to understand is the original graph is just this semicircle. So this was the 2D graph that you rotated in order to create this entire object. All right, guys, is that clear? So that's the most important thing to identify at first. All right, guys. So this is the main part of the curve that you're rotating. So now the next challenge is, okay, you need to know the equation of that original graph. Okay, so whatever the original graph that you rotated, you must know the equation of that original graph, because that's what we use for y here. Right, guys? Always for y, we use the original graph that we took for the rotation. So who is this? So guys, this is a semicircle, and not it's a part of a circle, right? So any circle, you guys know in P4, P2, a circle center AB, radius R follows the equation x minus a square plus y minus b square equal r square. This is the equation of a circle, right, guys? So over for this particular circle, the center is 0, 0. So it's gonna be x minus 0 square plus y minus 0 square equal radius is capital R. So capital R square. So x square plus y square equal capital R square. Right, guys? Can you see? So this is the main equation. And also, since you want to make y square the subject, you can write here, okay, y square equals r square minus x square because we want to input the y square value, right, guys? So now we have everything that we have everything that we need. All you have to do is substitute the y value into this equation. Okay, the y value from the main graph that you rotated, that equation has to be input here, and you can get the x bar answer, right, guys? And you can see here the integration happens with respect to x. You only have x bar, right? I think that's also pretty clear. Your solid is symmetric around the x-axis. So y bar is definitely 0. There's no need to find y bar. So x bar is found using this. So guys, you can see the integration happens with respect to x. So therefore, you have to input the x limit. The x limit starting from 0, and you can see it ends at capital R, right, guys? All you have to do is input this value, input these values over here, and perform the integration for the numerator separately, and perform the integration for the denominator separately. All right, guys? All right, guys. So let's input the value 0 to r. Y square is, so let's input the y square. Y square value is, right, guys, this guy. Okay. R square minus x square times x with respect to x. Denominator r square minus x square with respect to x. So the numerator, you need to expand the bracket, integration r square times x minus x square into x is x cube, right, guys? That's the numerator. Denominator is going to be, it's actually already ready, right, to be integrated. So there's nothing to do in the numerator. Already we have, yeah, inputting the y square value. So you don't have to square it again, right, guys? You can see I have already y square here, like, so we can directly go with this. You don't need to, extra input any other extra, you don't need to square it again, right? All right, so let's integrate. So this is r square times x. Integration is x square over 2, right, guys? X square over 2, and minus x cube, integration is x to the power 4 over 4, right, guys? And then your integration limits are from 0 to r. That's the numerator. Denominator is going to be r square x minus, because r square is a constant, so you integrate 1 and that gives you x. X square integration is x cube over 3, and your integration limits are from 0 to r. So let's input the limits now, replacing all the x values with r. Replacing all the x values with r. So it's going to be r square into r square. That's r to the power 4 over 2 minus r to the power 4 over 4. All right, guys, minus, and now you input x as 0. That's going to give you 0. Then this is going to be r square into x is r cube minus r cube over 3. Then compulsory minus in the middle, replace x with 0. All right, guys, can you see how we came to this point? So now r square, r to the power 4 over 2 minus r to the power 4 over 4. That's going to give you r to the power 4 over 4. Half minus quarter is a quarter, right? And this is going to give you, that's going to give you 1 minus 1 over 3. That's 2 over 3 r cube, right, guys? So simplify them, bring them into a single, a single fraction. So r cube over 4 into 3 over 2r cubed. This is how it becomes a single fraction, and I get 3r over 8. Right, guys? Can you see? So 3r over 8 units of distance, okay, measured from where the center of mass is at a distance 3r over 8. So here this is the g. So this g is at a distance 3r over 8 measured from this 0, 0. All right, guys. All right, guys. So final conclusion, you can write like this. The center of mass of a uniform solid hemisphere lies on the axis of symmetry and is at a distance 3r over 8. from the plane surface. Okay, so from the plane circle surface, the plane surface, it's at a distance 3 r away. So that's really important. All right, guys.